Let's focus for a while. All right, so the first one's the long division one. Okay? These aren't hard. They just take some time. That's why it's called long division. Okay? It's long, easy division, right? Yeah. Except I don't think that's right. So you made a mistake somewhere, but that's what we're doing now. All right, what do we have to do in this problem? Didn't have to do anything extra? Had to add 2 zeros, yeah. The x squared and the x. All right, I can see it's already gonna give me issues. All right, so all I concentrate on, the division part of these is really, really easy because all it is a monomial, one term, divided by another monomial, one term, each time. Each time I'm going to divide by x when I do the division. Okay? So the first division problem is x to the fourth divided by x. What does that equal? X to the third. All we're doing is subtracting 1 from the exponent. You guys realize that, right? That's all we're going to have to do every time we divide by x, right? Just subtract 1 from the exponent with the x. All right? Now, I take that answer. After the answer to the division problem that you do goes up above. Then you take the answer and you multiply it by both of these terms. And then you put it underneath these two terms. And everything will line up then for you. Okay? So x to the third times x is x to the fourth. And x to the third times 1 is 1x to the third. Since it's a positive times a positive, that's still positive, right? Now, in long division, what are we supposed to do now? Subtract, yes. Okay. Okay, so that red line is a subtraction symbol. So, what is 1x to the fourth minus 1x to the fourth? 0, right? That's what we want to happen every time at that spot, right? What's negative 4x to the third minus 1x to the third? Negative 5x to the third, right? Then you bring down, after you do that subtraction problem, you get one term, and you bring down the next term so that you have 2 terms. And then you start the division part over again. And again, all it is this monomial divided by x. All right, so what is negative 5x to the third divided by x? Right, negative 5x to the second. Just subtract 1 from the exponent, right? Everything else is the same. So now what do I do with that negative 5x to the second? I multiply by both of those, right? So again, we're just repeating this procedure that we've already done. So negative 5x squared times 1x is negative 5x cubed. And negative 5x squared times 1 is negative 5x squared. This negative 5x squared is the reason we added the 0x squared. So you have like terms there, that they're lined up. If we hadn't done that, that would be the 6, right? Could I subtract that from the 6? No, they're not like terms. So that's why we do that, just to hold those like terms and keep them lined up for you. It makes it easier. So again, we subtract at this point. Now, here's where we're making a mistake once in a while. What's minus a negative? Positive, it's addition. So this is negative 5x cubed plus 5x cubed, which makes sure they cancel out, right? And this is 0 minus a negative 5x squared, so that's 0 plus 5x squared. So that's a positive 5x squared there. And then we bring down the 0x, and we start over. 5x squared divided by the x is 5x, positive, right? And then I multiply 5x times x, and 5x times 1. So the 5x squared minus the 5x squared is nothing. Now I have 0 minus 5x, which is negative 5x, right? This time it's not minus a negative. It's a 0 minus 5, right? That's negative 5. Now I divide the negative 5x by x, which is negative 5. Multiply negative 5x times x, I'm sorry, negative 5 times x is negative 5x. And negative 5 times 1 is negative 5. I subtract. Minus a negative is addition, so I get 6 plus 5, which gives me 11, right? That's my remainder. So to finish my answer, which is up here, since it's a positive 11, I put plus 11 over x plus 1. So that's our answer for the long division. Questions? So don't forget to add the zeros if you need to. Hannah?
Is that always gonna like work if you do the like it's just only one right less than? So
Yes.
X,
The answer, you mean one
yeah.
exponent less? Yeah, that's usually what will happen, yeah. Unless, this is an x squared or something, but it's not really. Any other questions? Okay, number 2 is just like this, but we do synthetic, which is much quicker and easier, right? I mean, this isn't hard, it just takes long. That's why it's called long division, it takes some time. Again, I went really slow too. Okay, number 2, we're dividing by x minus 1. So what goes in the corner? Positive 1, right? So remember that. When you're doing synthetic division, if you're dividing by x plus something, then the number in the corner is negative. Oh, it was minus something, wasn't it? If it's x minus something like this one, then it's a positive in that corner. So I got a 2x to the 4th. There should be an x cubed, but there's not. So what do I got to put? 0. Then there's a 5x squared, so that's okay. There's a negative 1x, so that's okay. And then my constant, the 4th. So that's how I start synthetic. Make a line, give yourself some room to put a number between 0, 5, negative 1, and 4 in the line. Remember, this first 2 goes below the line. Some people put it above the line. So I always put that arrow just to make sure I don't put something there. But again, you don't have to do that. Now, what do I do at this point, Garrett?
I have no idea. I haven't been in the last 3 days.
3 days?
Yeah, it's the exam.
Oh my
Okay.
goodness.
Ooh.
It's about time you show up and stay in here. I have to start sitting on you so you can't leave.
Oh, you got it.
Gabe,
2 times 1.
yeah. We take this 1 in the corner times this 2, which is 2, and that goes above the line. Braden, what do I do with the 0 and the 2? Yes, you add in synthetic. Okay? In long division, we subtract, but in this, we add. So this is a 2. What goes here, Nate?
Another 2.
Good. Because we're just going 1 times that 2. What goes here, JR? Add.
7.
Thank you. Grace. What goes here? Good. Hannah. What goes here? Good. Drake. What goes here?
6.
Good. Abigail. What goes here?
10.
Very good. Questions, anybody? Alyssa, what's the answer?
X plus 9 plus 2x plus 7. Oh, to the second. Plus 7x plus 6 plus 10 over x squared.
Very good. So, this original problem was x to the 4th, right? The answer for the first one is always 1 less. Every year I get somebody who wasn't paying attention, Garrett, and put 2x to the 4th there. You won't do that, will you?
No, sir.
Thank you. Okay? So don't make that careless mistake. Check what the original exponent was. So this one is always 1 less for the first term of the answer. Questions? Okay. Number 3. It says use synthetic substitution to evaluate the polynomial for the given value. The given value was 2, so you put a 2. You do not switch the sign. Okay? So in this one, where it says x equals 2, it doesn't say x minus 2 or x plus 2. It actually says x equals 2. That is the number that goes in the corner. Okay?
Flip it if it says like x plus or minus.
Yes, you would flip it.
But if it gives you it, it's no.
Right. So number 3, when you do synthetic substitution, that's what they'll do. They'll tell you x equals on this type of problem. All right. So I have a positive 7 for the x to the 4th. There is no x to the 3rd, so I have to add a 0 again. Negative 5 for x squared. Negative 5 for x. And negative 10. The other thing that kids miss, if they miss, is they miss the signs. They put the wrong, if it's a minus 5x squared, you need to put minus 5 there, or negative 5. Sometimes we forget that. Let's not do that tomorrow. All right, so I got my 7. Cameron, what goes here?
14.
Thank you. Joe, what goes here?
Where are we at? 14.
Hunter, what goes here?
28.
Cole, what goes here? Audrey, what goes here?
I'm writing it down because I messed up.
Okay, we'll look at it. No, you're supposed to do with this and this. Yeah, what's 2 times 23?
Oh.
Ava,
41.
Kendra, Hannah, Robert, what's the answer?
And that's the third.
No,
No. Why not?
because you don't need that part.
Oh, answer 72.
Yeah, just 72. You don't have to do what Robert was starting. 7x to the third would have been right.
Oh,
But all we want is that. So since they call this synthetic substitution, what is this telling you, this 72? It's called synthetic substitution. The answer is 72. What is that telling us?
72 equals 2.
Well,
so
close.
synthetic of it.
72.
What?
You're substituting 72.
No. Close though.
X is 72.
Yeah. No. Wrong. What's X?
X
2.
So confident.
If I substitute 2 in for the X, what's the answer?
72.
72. That's what it's telling us. Okay?
Why can't you just do the equation?
Because it said to use synthetic substitution. So do it that way.
Wait. So if we just plug in 2 and get the answer, then
Yo, Dave.
You'll be wrong. I would mark it wrong.
Okay, but that's how like.
Yeah, that's how you could check. Yes.
What?
It's just a different way to figure that out. Okay?
Like that.
I like it better. I think it's quicker.
Oh, I love it.
Then a calculator?
Yeah.
No.
Okay. Factoring. Come on, let's stay focused. Nate, I need to take that from you.
Wait, why does he get a warning?
Because that's the first time I caught him. Was it times for you first time?
No.
Okay, that's what I thought.
Yeah, Nate.
All right.
Alright, Joe. Yeah, okay.
I don't know my phone. It's actually in my phone.
Good, keep it there. All right. So what is always the first thing we look for if we're supposed to factor? GCF, very good. Greatest common factor. Greatest means the biggest common factor, right?
Yep.
So looking at all 4 of those terms, is there a greatest common factor? No. So since it has 4 terms, what do we call this type of problem? A grouping problem. And when we group 2 at a time. First 2 and last 2. If this third term has a minus in front of it, like this one, put it inside the second group. All right? So I didn't really change the problem. I just kept it as an addition problem, right? It's okay. Now we go back to the beginning. We look for a GCF from each group. What's the greatest common factor between those 2 terms?
B squared.
B squared. What is 4b cubed divided by 1b squared? 4b. What is 3b squared divided by 1b squared?
Plus 3.
Positive 3.
And right, you have to pull the negative out when it's.
Oh, yeah, not there.
We're going to right now. You're correct. All right, so when you see that minus sign or negative sign in front of that third term, do what Hannah just said. Pull out that negative sign right there. Now, looking at these 2 terms, is there a GCF?
-4.
Yeah, it's 4 with that makes it -4. Okay? They don't have to both be negative for you to pull that negative out. okay? Whenever that's negative right there, you pull it out.
So what's the point of flipping it then?
And then you change that to.
When I divide, yeah.
Like instead of it being minus 1.
Well, now I'm gonna divide negative 16b by negative 4, which is what? Positive 4b. And I'm gonna divide negative 12 by negative 4, and what's that? Positive 3. Looking at the green binomials, are they the same? They are. That's what we want to happen. If they're not the same, Abigail, then we couldn't do any more of it. It wouldn't be factorable. But since they are the same, 4b plus 3 is one of my factors. Isabella, what's my other factor? Right, those two blue terms. Those two GCFs that you pulled out become the other factor. And then we're done, right? No,
Are we?
we're not. Because we call this a what? Difference of squares, right? And there's a certain way that we factor a difference of squares. We make two sets of parentheses. And then what do? Hunter?
Wouldn't you just simplify it out?
Well, we're factoring it. It's like a factor tree, right? We're gonna go further because we got
Yeah.
factors of this.
B minus 2, B plus 2.
How did you get those?
I just divided those by 2.
No, you didn't. You did the square root of both.
Well, come on.
No, it's not.
Oh,
Okay, 8 divided by 2 is what?
4.
What's the square root of 8? Is that 4? No.
Oh, I know the square cube of 8. I know the square cube of 8.
No, you mean the cube root of 8?
Yeah.
Yeah, that's 2.
That's 2.
Way to go, Joe.
Technically, I wasn't wrong for dividing by 2, though.
No, you're not dividing. You're taking a square
But
root.
technically, I got the right answer.
You had the right answer, yes, but you told me the wrong thing.
I had to do it.
Still got the right
It's like
answer.
you like copied it.
Come on, let's stay focused. Liz.
Oh, wait.
What did we do here?
What I thought.
Wrong. Why? Yeah, it's a GCI.
I thought you said wrong.
No, I said why not?
Oh.
We have to like,
I
did like-
No, you are correct.
well,
I thought that was right.
oh, one of them. Yeah, yeah.
Come on, Joe, shut your mouth. There's a GCF. What do we call that binomial in the parentheses? Yeah, it's two terms, right? Or it's got a special name. Timmy? You don't know what we call it? It's called a difference of cubes. So, the way you factor a difference of cubes is you make room for two terms, binomial, and you make room for three terms, a trinomial. Autumn, how do I get the binomial? Yeah, cube root. Hunter would say divide by 3, but
Yeah.
that's not what we're doing. Right? What is the cube root of 27y cubed?
3y.
3y. What is the cube root of 64?
6.
4. What symbol between them? Minus. These are the same. Okay? What do I have to do to find this first term of the trinomial? Square the 3y. What is 3y times 3y? 9y squared. The mistake that a few people made, they squared the y, but they forgot to square the 3, so they put 3y squared. Okay? So remember, you're squaring both numbers, the 3 and the y,
Wait, why are we squaring?
because that's what you do to get this one.
How do you mean
That
that?
just times it by 2.
Because there's going to be 3 terms in here, Hunter. To factor this correctly, this is the procedure. All right, what goes in the middle?
Plus,
Plus.
Wait.
Why, Joe?
because it's always opposite of the first one.
Correct, very good. How do we find that middle one, Drake? Thank you.
Wait, don't
I thought I had always asked good questions.
Don't you multiply
Yes, multiply what?
before the 3?
Which is?
12.
But since it was 3y, it's
12.
12y. Very good, sir. You're correct. You multiply the 2 terms from the binomial together to get that middle term. How do I get the third term of the trinomial?
You
Square is 4.
Square the 4. And it's always going to be what sign there? Plus. Always plus. Because if you square positive 4, you get 16, or if you square negative 4, you get a positive 16, right? So it doesn't matter what this symbol is, you're going to get a positive third term. So that's the answer. That's factored now. Not a problem. Okay?
Nice.
Questions? Okay. You're so smart. Good job. Last one. Is there a GCF for all 4 terms? No. So, since there's 4 terms, we're going to do what?
Divide it.
Group it, right? And since the 72 had a minus in front, we're going to keep it inside the group. So, how do I start? Excuse me, how do I start this, Chelsea?
Wait, me?
Yeah, you, Chelsea
Oh.
Woods.
Yeah, you can find the GCF is the 2x
Right,
cubed in the x squared,
very good, which is?
x squared.
Good. Grace. What's in here, what's left?
2x.
What's that divided by that?
1.
Yeah, don't forget it. Some people think, well, they're the same, so I just cancel them out, so there's nothing there. No, it's actually 1, so you have to put that plus 1 in there. Okay? JR, what comes out of here?
Great common factor is negative 36.
Good, good. So some of you had pulled out a 2, some a 4, some a 9, some a 12, some a 6. All those are common factors, but they're not the greatest common factor. 24 wasn't. All right, so the greatest common factor is 36, and like JR said, it's 2x plus 1 when you divide negative 72x by negative 36, and negative 36 divided by negative 36. So, Braden, what do I write now? Good. What else?
X squared minus 3.
Good. And then we're finished, right?
No.
No, Ava, what do I do?
Square roots of the
Square roots, very good. Then what? Plus and minus. Would minus and plus be okay? Yes. There's our answer. Autumn.
So, Is it wrong then if you don't do -36?
Yeah,
You get
not,
too hot.
not correct.
Yeah, I think you get extra.
We're not done, I got one more for you to do.
I think-
Try this one, this is for more practice, since we've got time.
What? He's hot. Okay,
What?
you break after after class?
Back to that, please.
Why?
You guys have done a good job these last 2 days, finishing up strong this second 9 weeks. But remember, this is our first grade tomorrow. It's our first grade of the new 9 weeks, right? So it'll go on next Tuesday. It'll be the date of that, even though we're doing it tomorrow.
Wait a hot minute.
It is a perfect cube.
Robbie, that's right.
One thing's wrong. Figure out what it is. Middle sun. Very good, Alyssa.
Oh, there's John on something. That's what you got?
Trying to go with
Hey, Doug.
You have to keep going up, you gotta do
Yeah, all right.
Then you have to put the next.
Am I doing it right? Listen.
Yeah.
Good on you. You're actually using the calculator for that? That's right, so far.
I did this.
Or a sum of
Oh, I
cubes.
didn't like it.
That's right. Gotta go another step.
Oh.
I'll go. You're ready.
Oh, I don't know about that.
I'm getting all of them. That's not a difference in squares. No, you can do a binomial and a trinomial. Binomial, trinomial. No, it's not right. Your binomial's right.
I think I did it.
Okay, what's the GCF? 4x squared. Okay, come on. Watch. What do we get? X cubed plus 125. 125 is a perfect cube. X cubed is a perfect cube, right? So I have to do my binomial trinomial thing. Right, what's the cube root of x cubed? Cube root of 125. What's x squared? What's 5 times x? What's sine? Minus, opposite, right? And then what do I do with the 5? Square it, plus 25. Okay? So just wanted to practice one more of those with you. Good job. See you tomorrow. Look good, feel good. You are good. You guys are good. Except for Eric.
I.
One point. Sounds like a good plan.
Just